All right, everybody, what's up? This video, we're going to look at conic sections. And this is the conic sections that's in the calculus book. All right, so let's go ahead and get started. So first thing we're going to look at is parabolas. And so we know that a parabola, it's going to either open up, or it's going to open down, or it can open to the right, it can open to the left. Now, here we have the focus of the parabola. We have the directrix. It's a line that's p distance away from the vertex, which is your vertex is right here. The focus is a distance of p from the vertex also. And the coordinates of the focus, that's going to be dependent on how the parabola opens, if it opens up, down, or left, right. We'll look at that in a minute. I've got some more drawings down here. But yeah, this is the vertex, this is the focus, this is your directrix. It's a line. It's y equals negative p. The focus is 0p. This is your x-axis, y-axis. And this line here that goes through the focus that's perpendicular to the directrix, that's called the axis of the parabola. So let's look at it in a little more detail. Let's look at this. It says an equation of the parabola with focus 0p and directrix y equals negative p is x squared is equal to 4p times y. And then if we interchange the x and y, we have y squared equals 4px. Now let's look at this. This equation up here, this is for a parabola that opens up or down. Okay. Obviously, if this term here is positive, it's going to open up. If it's negative, it'll open down. And then this one down here where we have the y squared, that is going to open left or right. So if this is positive in front of the x, then it'll open to the right. If it's negative, it'll open to the left. So let's look at each one of these cases here. So you can see here, here's a parabola that opens upward. This is x squared equals 4py. P is positive. Okay. So our focus is 0p. And now the 0p, that's when the vertex is at the origin at 0, 0. We're going to see where it's not necessarily just 0p. We'll have some examples of that. And then you can see the directrix is y equals negative p. And then here's one that opens downward. You can see it's the same thing. It's just p is less than 0. So you can see that the focus is, it's like, here's the parabola, and the focus is going to be inside the parabola here. See this? There's your focus. And then the directrix is going to be here or here, depending if it opens up or down. And then here's the parabola that opens left or right. You can see it's the y squared equals 4px. See, if it opens to the right, p is positive. If it opens to the left, p is negative. And of course, here's your focus when it opens to the right. Your directrix is here. These are both p units from the vertex. The directrix is p units from the vertex, and the focus is p units from the vertex. And same thing here. It's just this one opens to the left. P is negative. All right. So let's look at some examples. We've got quite a few examples to work. So for this, it says find the vertex, focus, and directrix of the parabola and sketch its graph. All right. So this is x squared. So we know we've got x squared equals 4px. That's the equation of our parabola. Okay. So we can see that 4p See, 4p is what's in front of x. I'm sorry, not x, y. Okay, x squared is equal to 4py. So you can see that 4p is in front of y. That's equal to 6. And so we get p is equal to 3/2. So that's p. Now, what's our vertex? Well, our vertex is 0, 0. Our focus, we got to find the vertex, focus, and directrix. So the focus, well, remember what that is? That's what? See, we've got x squared equals 6y. It's in this form here. So our focus is 0p, and we know this parabola opens upward because it's positive in front. Well, we're at this one. It's positive in front. So we know it's going to open upward. So our focus is 0p. So, you know, what I like to do is, you know, just come over here and kind of sketch what you have. All right, so if we plot the vertex, that's 0p, and we know it opens upward, right? We know it opens upward. So we know the focus is going to be up here. The directrix is going to be down here. So our focus is going to be, it's going to go up p units, right? 3.5. So it's going to go up to right here. There's your focus. And so, well, what's the coordinates of that point? The coordinates of that point is 0, 3/2. Okay? And then the directrix, that's going to be a horizontal line. It's p units this way. So it's going to go through this point here where y is negative 3/2. So there's your directrix. Y equals what? Negative 3/2. Remember, a horizontal line, that's the equation y equals. And it's going to be y equals, well, remember this is y equals negative p, right? That's what it told us up here. See, y is equal to negative p. And so that's y equals negative 3/2. And so there's our directrix. Y equals negative 3/2. So we found the vertex, the focus, and the directrix, and we sketched the graph. Now you can come in here and you can label this point. I'm not so sure I'm going to label them on every one because of the room. And then there's your vertex. Your vertex is the point 0, 0. It just kind of gets kind of cluttered up in there a little bit. So, but yeah, there it is. You can see it's really not that difficult. These are really pretty easy to do, especially when the vertex is at 0, 0. Yes, we're going to work some where the vertex is not 0, 0. So we'll do one of those in a minute. All right, so let's look at this one. All right, so notice we've got the y squared term in there. So we know this vertex is going to either open left or right. But let's get it in the form that we need. It's y squared equals 4px. That's the form. Remember, it's x squared equals 4py, or y squared equals 4px. So we need to get this 10x to the other side. So we've got y squared equals negative 10x. So right there, we know this thing is going to open to the left. All right. And so let's look at this. So we know the vertex is at 0, 0, and we know it's opening to the left. All right. And we know that the focus is going to be over here, and our directrix is going to be a vertical line over here. So let's figure out what P is. So we've got negative 10 in front of X. So 4P is equal to negative 10. So 4P equals negative 10. So P is equal to negative 5 halves. All right. So negative 5 halves, that's negative 2.5. And so we know our focus is right here. Okay. And so our focus is what? Negative 5 halves, 0. All right, so there's the focus. Now we need our directrix. So the directrix, it goes P units this way. All right, so that's going to be a vertical line right here. And that's going to be X equals 5 halves. Now, remember what I said, that the directrix is either Y equals, look up here. The directrix is Y equals negative P. See, Y equals negative P, or X equal negative P. See, X equal negative P. And so we can see that P is negative 5 right here. So you can see this would be X equals negative P. So negative 5 halves, which gives us the positive 5 halves. Okay. So that's nice when the vertex is 0, 0. And let's write this down. X equal 5 halves. And of course our vertex is 0, 0. All right. So real simple. The main thing is you need to find P, so you can get the focus, you can get the directrix. And then, based on if it's X squared, it's going to open up or down, depending on if P is positive or negative. And then the Y squared, that's going to either open to the left or to the right, depending on if P is positive or negative. All right, so let's look at this next problem. All right, so this one kind of looks funny, doesn't it? It doesn't look like notice here we've got there's a X squared term. So it really doesn't look like that, does it? It doesn't look like that at all. So maybe we need to do something to it. So what I'm thinking is keep all the X terms over here. Since the X is squared, let's keep the X over here and let's get everything else to the other side. So that's going to be 2x squared minus 16x equals 3y minus 38. I just moved the 3y and the 38 to the other side. And so now maybe I need to complete the square on this side over here. And remember, to complete the square, you got to have a 1 in front of your squared term. So I'm going to factor out a 2. And I'm going to leave a little space here. That equals 3y minus 38. So what do? We half the 8, that's 4. And then we square the 4, that's 16. So since I added 16 in here, I have to add 32 over here. And now you might be thinking, well, wait a minute, why are you adding 32? You added 16. Well, I added 16 in here, but on this side, I actually added 2 times 16. See, if I distribute that 2, that's 32. So I have to add the 32 over here. And so now this part right here factors. That's going to be 2 times x minus 4 squared equals 3y minus 6. And it still looks kind of not right. So maybe what we can do here is factor out a 3. So that's going to be 2 times x minus 4 squared equals 3 times y minus 2. And then still I need to do something because see, I've got an x squared here, but there's not a number in front. So let's divide everything by 2. And so that's going to be x minus 4 squared equals 3/2 times y minus 2. All right, so now it's looking more like this. I know it doesn't quite look like that because this is just an x squared, this is just a y. But kind of think of it like this. Look at it like this. Look at it as x minus 0 squared. That's the same thing as x squared equals 4p times, and then y, that's also y minus 0. And remember, this right here, our vertex was at 0, 0. See, there's your, you can look at that 0, 0. So over here, we would have our vertex to be what? 4, 2. There's your vertex. Okay. And now remember what we need to find. We need to find P so we can get our focus and our directrix. So we can see here that 4p, right? The 4p is equal to what? 3/2 is equal to 3/2. So we get P is equal to 3/8. So there's P. So let's go ahead and plot the vertex. Let's sketch our parabola in there and use that to figure out what our focus and directrix is. So if I draw this, so I've got 1, 2, 3, 4, 1, 2. All right, so if I plot my vertex, that's the point 4, 2. And I know this parabola is going to open upward, right? So I know my focus is going to be here, and my directrix is going to be down here. And this is my vertex 4, 2. Now, think about this, okay? Think about this. My focus is going to be the point what? It's going to be right here, okay? Right in here somewhere. So we know the x-coordinate of the focus is going to be 4. Well, what's the y-coordinate of the focus? Well, I've got to go from here up, right? So I've got to go from 2 up 3/8. So I'm going to need to do what? 2 plus 3/8, which that's going to be 19 over 8. So that's 19 over 8. And so my focus will be about right in there. And like I said, I'm not going to label these. You can label them on your paper because you can probably spread things out more than me and get those points in there, and it won't be as cluttered up. And then I need my directrix. Now the directrix, that's going to be a line what? Y equals, right? Y equals. So that's going to be y equals, well, what is that line? Well, that's this line right here, right? It's 3/8 down from this point. So it's going to be y equals, and that's going to be from what? I'm going from 2 down 3/8. So I've got to do 2 minus 3/8, which is 13 over 8. So that's 13 over 8. So this would be the line y equals 13 over 8. And that's what I'm talking about. Whenever you're having to find the focus, the directrix, vertex, all that stuff, the easiest thing to do to get your focus and directrix is to have a picture of it. You know, look and see, okay, so this parabola is opening up. So I know to get to the focus, I'm going to have to add P to the y coordinate. To get to the directrix, I'm going to have to subtract P to the y coordinate. If this were opening down, Well, it would just be the opposite. If it was opening left or right, I would have to add and subtract p to what? Well, look, if it's opening this way, then I would have to add and subtract to the x coordinate. Okay, it just comes in real handy if you can look at a picture of it. Okay. All right, so let's look at our next examples. Oh, now we've got ellipses. All right, so for the ellipse, we have an ellipse here. We have the points, negative a0, a0, 0b, and 0, negative b. And this right here with an ellipse, you can see here's one that's kind of the long way is along the x-axis, and this one it's along the y-axis. Okay, this would be your x-axis, y-axis. So in this one, okay, we'll look at this picture in a minute. Let's look at this picture. So in this picture, we have the negative a0 and a0. These are called your vertices. And the line that connects your vertices, that's called your major axis. And then this line here, that would be your minor axis. All right. And then the points here, negative C0 and C0, these are called your foci. All right. And the equation of this ellipse would be x squared over a squared plus y squared over b squared equals 1, where a is greater than or equal to b. Okay, so this a is greater than or equal to b. And then over here, notice it's similar, but remember over here how the negative a0 and a0, those are your vertices. Well, here, 0a and 0 negative a, these are your vertices, and then so your major axis would be here, the line that connects 0a and 0 negative a, and this would be your minor axis, the ones that connect negative b0 and b0, the line segment that connects those. And then your foci is 0c, 0, negative c. And this equation would be x squared over b squared plus y squared over a squared equals 1, where a is greater than or equal to b. So if the larger number is underneath the x squared, your major axis is going to be horizontal. And then if a squared, the larger number, is under the y squared, your major axis is going to be vertical. Okay. Let's see. All right. And so here we have it. Here we have the ellipse. Just like we said before. Here we go. It's x squared over a squared plus y squared over b squared equals 1, where a is greater than or equal to b, and both of them are positive. Or a is greater than or equal to b, which those are both positive, has foci plus or minus c, 0, where, okay, so now they're telling us what c is. C squared is equal to a squared minus b squared. So that's how we would get c. We could use this right here to get c. And has vertices plus or minus a 0. And you saw that up here, your plus or minus a 0. All right. And then you can see where a squared is underneath the y squared, and a is greater than or equal to b, which both are positive. It has foci 0 plus or minus c, where c squared is equal to a squared minus b squared, and the vertices are 0 plus or minus a, and we saw that here. See the 0 plus or minus a, there's your major axis there. All right. All right, so let's look at some examples with the ellipse, and then we're going to look at some examples with the hyperbola, and then we've got some more examples where we're going to actually find the equation of the parabola, ellipse, and hyperbola when they give us information. So here, find the vertices and foci of the ellipse and sketch the graph. All right, so notice one thing when we're graphing the ellipse. Notice what both equations are. They're both equal to 1. So this 144 here, we need that to be a 1. So what we're going to do is we're going to just have to come down here and divide everything by 144 to get that to be a 1. So that's going to be x squared over 16 plus y squared over 9 equals 1. All right. So we know our major axis is going to be horizontal, right? Because the larger number's underneath the x squared. All right, so we can see that a squared is 16, which tells us a is what? A is 4. And then we have b squared is equal to 9, which tells us b is equal to 3. All right, so we want to find the vertices and we want to find the foci. Well, we know the vertices. That's what? A, remember, it's plus or minus a 0, or it's 0 plus or minus a. But we know we've got the larger right here. So look, let's do this. Before we write it down, let's just kind of sketch it. All right, so a, that's underneath the x squared. So we got here and we've got here. The b, that's going to be up 3, down 3. And let's see if I can draw this half decent. All right, there's my major axis right here. So we know our vertices, see that's 4, 0, negative 4, 0. This is 0, 3. This is 0, negative 3. So we know our vertices are plus or minus 4, 0. There's the vertices. And we know the center is at 0, 0. Yes, we will work one in a minute where the center is not at 0, so you'll be able to see that. So we need to find out what C is. So let's see, what is C? So we know C squared is equal to A squared minus B squared. And so C squared is equal to 16 minus 9. See, there's A squared, there's B squared. And so this is equal to 7. So this tells us C is equal to the square root of 7. So that tells us our foci is at what? Well, let's see, square root of 7, that's about 2 point something. So we know our foci is here and about here. So that's going to be plus or minus square root of 7, 0. There's our foci. See, there's our vertices, there's the foci, and there's the center. I don't know what all it tells. Find the vertices and foci of the ellipse and sketch its graph. Well, we go ahead and list the center too. And so there you go. So this would be the point square root of 7, 0. This would be the point negative square root of 7, 0. Look, don't make this any more difficult than what it is. Okay. The foci, just know the foci is going to be along the major axis. Okay. So, once you get A, and remember A is underneath, A is the larger number. Okay, A is the larger number. So look, if the larger number is under x squared, the major axis is going to be along the x-axis. If A squared is under y squared, or the larger number is under y squared, the foci are going to lie along the major axis, which in this case is horizontal. Okay, that's how you need to look at it. So, you know, just plot it out, and then that's going to help you get your point coordinates. All right, so let's look at this one. All right, so we've got x squared over 2 plus y squared over 4 equals 1. This is already in the form we want it in. Now, which way is the major axis? Is it horizontal or is it vertical? Well, it's vertical, right? Say the larger number is under y squared. Okay, so we know here that b squared is equal to what? Square root of 2. Remember, b is the smaller number. It's under x squared here. I'm sorry, not square root of 2. B squared is 2. I was getting ahead of myself. So b is equal to the square root of 2. And here a squared is equal to 4, which tells us a is equal to 2. All right. So, you know, just come over here. All right, so let's see. A is 2. That's underneath the y term. So that tells me I know I'm going to go up 2, I'm going to go down 2. And then b is square root of 2. Square root of 2 is 1 point something. So I'm going to go over 1 point something and over to the left 1 point something. And b is square root of 2. And so then I can draw my ellipse in. I know that doesn't look like a very good one, but there it is. And so this is going to be 0, 2, right? Because we went up 2, see? See, we went up 2. A squared is underneath y squared. This is 0, negative 2. And then this is square root of 2, 0. This is square root of 2, negative square root of 2, 0 for this point. All right. And so let's see, our foci, that's going to be along here, right? So we know c squared is equal to what? A squared minus b squared. So c squared is equal to 4 minus 2. See the 4? That's a squared. The 2 is b squared. And so that's 2. So c is equal to square root of 2. So my foci, that's along the major axis, which is vertical in this case. It's going along the y-axis. So I'm going to go up square root of 2, down square root of 2. And so you can see the foci, that's what? The x-coordinate's going to be 0 on both of them, and then I've got plus or minus square root of 7. Not square root of 7. Where did 7 come from? Square root of 2. I think that was in the previous problem. I guess I still had that 7 on my mind. And the vertices. So remember, these are your vertices, 0, 2, and 0, negative 2. So that's 0 plus or minus 2. That's the vertices. And then we have spell it right. And of course our center in this case is 0, 0. They didn't ask us for the center, but you know, we got it. We wrote it down. All right. So hopefully that problem made sense. See, it's not difficult to do this stuff, so you know. All right, let's look at the next one. So this next one, well, this kind of looks funny, doesn't it? It kind of looks similar to that one we did with the parabola. So, you know, I see something like this. First thing that pops into my mind is complete the square. So we've got x squared. I'm going to group the x terms together. And I'm going to group the y terms together. And the constant term, I'm going to move to the other side. All right, so let's complete the square. So I've got x squared plus 2x plus, now look at this. Remember, I can't have a number in front of my squared term, so I'm going to factor out that 3. So that's 3y squared minus 4y, leave a little space there, equals negative 10. All right, so I half the 2, that gives me a 1. 1 squared is 1, so plus 1, plus 1. And then I half the 4, that's 2. Squared the 2, that's 4, so I'm adding 4. So remember, I'm adding 4 in here, but 3 times 4 is 12, so I have to add 12 there. And so that's going to give me what? X plus 1 squared plus 3 times y minus 2 squared equals 3. All right. So remember, this has to be a 1. Okay, that has to be a 1. So I've got to divide everything by 3. Now, I want you to know here, I'm not dividing because of this 3. I'm dividing because this is a 3. Because this over here has to be a 1. Okay, so that's going to leave me with x plus 1 squared over 3 plus y minus 2 squared. Now, the 3's cancel out. Let's go ahead and write this over 1. Okay? So we can see. Now, let me ask you this. What is this? Is this a squared or b squared? This is b squared. Okay? Because remember, b is smaller than a. All right? And that equals 1. So for this problem, I have a squared is equal to 3, which that tells me a is equal to the square root of 3. Here, b squared is 1, which tells me b is equal to 1. All right? So, oh, and look, this one's different. This is, my center's not at 0, 0. So this tells me that I'm going to have a center at what? Negative 1, 2. Okay? Negative 1, 2 is my center. All right, let's see. 1, 2, 3. All right, so let's go ahead and plot the center. So that's going to be negative 1, 2. There's my center. Okay, and I think what I'm going to do, I'm going to put the center in a different color so it'll just stand out a little more. All right. Now, is my major axis horizontal or vertical? That's right, it's horizontal because a squared is underneath the x term. Okay? Remember, if a squared is under the x term, my major axis is horizontal. If a squared is under the y term, my major axis is vertical. All right? So, what I need to do now is let's plot my vertices. Okay, let's plot my vertices. All right, so to plot my vertices, that's going this way, right? So a is square root of 3. So I've got to do negative 1 plus the square root of 3 and negative 1 minus the square root of 3. So if I do negative 1 plus the square root of 3, that gives me 0.732. So it's not quite 1. So that's going to be about right in, that's going to be about right in here. And then if I do negative 1 minus the square root of 3, that's negative 2.7. So that's going to be about right in here. Okay, so let's just write that out. So this is the point negative 1 plus is negative 1 plus the square root of 3. That's my x coordinate. My y coordinate's 2. And then the coordinate for this point is negative 1 minus square root of 3. That's my x coordinate. And my y coordinate is 2. So for the vertices, I just went to the center. I added square root of 3, and then I subtracted square root of 3. The y coordinate stays the same. That's at 2. See, I'm just moving horizontal. Now, I need to plot my other point. So B is 1. So from here, I need to add 1, and I need to subtract 1, right? So this is going to be the point negative 1, 3, and this is going to be the point negative 1, 1. And see, here's my ellipse. There's my ellipse. All right, so that gives you a good sketch of it. And so my vertices, well, what is it? It's negative 1 plus or minus square root of 3. And then my y coordinate is 2. Okay. Now we need the foci. So remember, c squared is equal to a squared minus b squared. So c squared is 3 minus 1. See, a squared is 3, b squared is 1. That equals 2. So this tells me c is equal to the square root of 2. So how do I plot my foci? Well, I've got to go to the left square root of 2, and I've got to go to the right square root of 2. So my foci, it's gonna be about right in there. I know it doesn't look like it's the same distance, but it's supposed to be. Okay, from here to here and here to here, those are supposed to be the same distance. It's just the marks I made, they're not equally spaced, so it's not going to look quite right. But let's come over here and get the foci. Now, so how did I get the foci? Well, I went from the center and I added square root of 2, and I subtracted square root of 2 to what? To the x value. So that's negative 1 plus or minus square root of 2. And then, of course, my y value, that stays at 2. So there's my center, my vertices, and my foci. All right. So that's the examples on an ellipse. So now let's look at the hyperbola. So a hyperbola, it's similar to the form that the ellipse is in, but remember, the ellipse had a plus in between. And so we've got x squared over a squared minus y squared over b squared equals 1. There's a subtraction sign between them. Okay. And then notice over here we got y squared over a squared minus x squared over b squared. What's the difference here? Okay. So remember, a is always over here. A squared and b squared, they're always they're like this. It doesn't switch up. The a squared doesn't necessarily stay under the x squared, or all the time like it did when we were doing the ellipse. It can be under the y squared. The a squared is going to be on the left hand side of the minus sign. The b squared is going to be on the right hand side of the minus sign. So if the x squared comes first, your hyperbola is going to open left and right. If the y squared term comes first, it's going to open up and down. Okay? And, whatever number's under y, that tells you, okay, if the y squared's first, we're going to go up a, down a. If the x squared term's first, we're going to go to the right a to the left b. To the left a, not b, a. And then we have our asymptotes here. So if the x squared term's first, that's going to be, your asymptotes are going to be y equals negative b over a times x and y equals b over a times x. We got the line with the positive slope and the line with the negative slope. This right here tells us that when we draw our hyperbola in, that the hyperbola is approaching these asymptotes. They're not going to cross them, they're just going to get close to them. And then if we have the y squared term first, well, our asymptotes, they're y equals negative a over bx, y equals a over bx. So just remember, if the x squared terms first is on the left hand side of the minus sign, it's going to be b over plus or minus b over a. If the y squared terms first, your asymptotes y is going to be plus or minus a over b. Okay, so, and then of course you've got your foci, 0, that would be 0, c, 0, negative c. Okay. All right, so let's look at this. So here we go. We have the hyperbola x squared over a squared minus y squared over b squared equals 1, has foci plus or minus c, 0, where c squared is a squared plus b squared. Remember, it was a little different on the ellipse. It was a squared minus b squared. For hyperbola, it's a squared plus b squared. Vertices, plus or minus a 0, and asymptotes y equal plus or minus b over a x. All right, and then if we have a hyperbola y squared over a squared minus x squared over b squared equals 1, we have foci 0 plus or minus c, where c squared is a squared plus b squared, vertices a plus or minus, and then vertices 0 plus or minus a, and asymptotes y equals plus or minus a over b x. Now, look, don't get hung up on this, how the points are written. Like I told you, just make a rough sketch of the graph, and it's going to be easy to see how your coordinates need to be. Just remember, if x squared is first, it's going to go left and right. If y squared is first, it's going to go up and down. Okay? So you can see your points, you're moving this way. You're moving along the x-axis. So yes, your x coordinates are going to change. Y is going to be 0. If the y squared term comes first, it's opening up and down your hyperbola. See, there's your point, 0c, 0a, 0 negative c, 0 negative a. The x, see the x value is staying 0. The x coordinates are 0. All right, so let's go ahead and look at this example. So once again, find the vertices, foci, and asymptotes of the hyperbola and sketch its graph. All right, so once again, we know this right here, it has to be a 1 here. So we're going to divide everything by 144. And so that's going to give us x squared over 16 minus y squared over 9 equals 1. Now, let me ask you this. Your hyperbola, is it going to open left and right, or is it going to open up and down? Well, which one's first? X squared is going to open left and right. Okay? And so we see here a squared is equal to 16, which tells us a is equal to 4. B squared is 9, which that tells us b is 3. And then, let's go ahead and find c. So we've got c squared is a squared, 16, plus b squared, which is 9, which is 25. So c is equal to 5. All right, so let's make a quick sketch of it. So let's say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so there we go. So A, okay, we're going to move what? 1, 2, 3, 4, and 1, 2, 3, 4. See, it's moving what's underneath the x squared. A squared is under x squared, so we're moving forward, left, and right. B squared is under y, so we're going to move up and down 3. So up 3, down 3. And our foci, well, we'll get to that one in a minute. So what I like to do is you can draw this box in there. I'll usually draw this box in there. It kind of helps you draw in your asymptotes. So our asymptotes, that's y equals, okay, so the x squared comes first, so that's what, plus or minus b over ax. And so in this case, y is equal to plus or minus b over a, so that's 3/4 x. Here's our asymptotes. I think that's one of the things they ask. So there we can circle that. There's your asymptotes. And a good way to draw those in, you can kind of just do this right here. And then there you go. And then you draw your hyperbola in. Oh. All right. So let's see, what are our vertices? We got to find those, don't we? And we need the foci. I'm going to plot the foci too. So the vertices, well, this is the point, what, 4, 0 and negative 4, 0. This is the point 0, 3 and 0, negative 3, right? So our vertices are here along the x-axis, and that's the plus or minus 4, 0. And let's plot our foci. C is 5, so we're going to go 5 and 5, right? 5 units to the right of the center. We can say the center is 0, 0. That's right there. So we're going to go 5 units to the right, 5 units to the left. So our foci would be plus or minus 5, 0. Okay. So there's your vertices, foci, asymptotes, and our sketch. Okay. So the vertices, foci, the asymptotes, there's the sketch of our graph, and we went ahead and put the center as 0, 0. All right, let's look at another one. So I've got y squared over 25 minus x squared over 9. All right, so how in the world are we going to do this one? Well, let's see. We've got a squared is equal to 25, which tells us a is equal to 5. Remember, a squared is always over here. And we got b squared is 9, and so b is equal to 3. And we can go ahead and find c. C squared is equal to a squared plus b squared, which is 34. So c is equal to the square root of 34. That's a nasty number, isn't it? It's fine, though. All right, let's go ahead and do our asymptotes. So our asymptotes, that's y equals plus or minus. Now, oh, look at this. The y squared term comes first. So that's a over bx. So y is equal to 5 plus or minus 5/3 x. There's your asymptotes right there. All right. So let's come over here. So let's say we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. So let me ask you this. When we do A and we go 5 units, do we go 5 to the right, 5 to the left, or do we go 5 up and 5 down? That's right, 5 up and 5 down. See, the a squared is underneath y. And so we're going to go up 5 and down 5. Okay. And then b, we're going to go to the right 3 and to the left 3. Now, that's not to scale at all, but oh well. And then, just kind of sketch this box in there. And, when you're drawing these things, be a little more careful of how you do your tick marks. I mean, I'm throwing them in there. So let's draw our asymptotes in there. And we know, the y squared is first. So we know that this thing's going to open up and down. And of course, we can see the center is 0, 0. And then we need what? We need the vertices. And we need the foci, right? Okay, so we can see on the vertices and the foci, the x-coordinate is 0, right? Let's see, the foci, that's square root of 34. The square root of 34 is 5 point something, because 6 squared is 36. So if we put in another tick mark here, the foci is going to be about right in there. There's your foci. So here's your vertices, this one and this one. This is your foci. I'm not going to label them with the point coordinates. You can do that, but I'm not going to do that. It gets just too cluttered up. So the vertices are going to be 0 plus or minus what? 5, because I went up 5 and down 5. The foci is going to be 0. What did I do? I went up square root of 34 and down square root of 34. See, that C value, that tells you how far you go from the center of it. Okay? And so there's your graph. See, this line here, this asymptote here, that's y equals 5/3 x. This line right here, that's the line y equals negative 5/3 x. Okay? All right, so let's look at this next example. This one kind of looks weird like one of the other ones we worked, but we know what to do here. We complete the square. So what I'm going to do here is I'm going to group the y terms together and the x terms together, and that equals 4. And so what do you think we're going to have to do? We're going to have to complete the square, aren't we? All right, so in order to do that, the number in front of the squared term has to be a 1. And so I'm going to factor out a 9. And then here I'm going to factor out a negative 4. So that's negative 4 times x squared plus 2x. And you're factoring out a negative, so that has to change to a positive, equals 4. All right. So I half the 4, that's 2, and then I square the 2, that's 4, so plus 4. So 9 times 4, that's what? That's 36. And then I half the 2, I square it. I half the 2, which is 1, and then I square the 1. 1 squared is 1. And so I added 1 in here, so I'm going to come out here and subtract 4. Now, why did I do that? Well, you can see over here, look at this, 9 times 4 is 36. So I added 36 on this side, so I add 36 over here. But look over here, the 1. I've got negative 4 times 1 is negative 4. So it's like I subtracted 4, so I got to come over here and subtract 4. All right? And so this is going to give me 9 times y minus 2 squared minus 4 times x plus 1 squared equals 36. And then, of course, we want the 1 right here. So I'm going to divide everything by 36. So that's y minus 2 squared over 4 minus x plus 1 squared over 6 equals 1. All right, so this one we can see the center is not at 0, 0. Okay, we can see the center is not at 0, 0. Let's go ahead and write the center down. How about you write the center down? Just write it down real quick, or think about what the center is. Now let me ask you this. Did you think the center was 2, negative 1? Well, it's not. It's what? Negative 1, 2. See, here's your x, here's your y. So it's negative 1, 2. Okay? There's your center. Now, let's go ahead and get a and b. So we've got a squared is equal to 4, which tells us a is equal to 2. B squared is 9, which that tells us b is 3. And then we've got c squared is equal to a squared plus b squared, which is 13. So c is equal to square root of 13. All right, so let's start plotting these things, see what the coordinates of our points are going to look like and all that good stuff. All right, so let's just plot the center, negative 1, 2. And let me do that in a different color again. Let's do it in red. Maybe we can see it a little better. So there's our center. So everything's going to come off that. Okay. So let's see. The a term is under y. So that means we're going to move what? We're going to move up 2 and down 2 from where the center is. So we're going to go up 2 and we're going to go down 2. Okay. And then the b term was under x. And you know something, I have no idea why I wrote a 6 there. That should be a 9. Man, I'm having all kinds of little mess ups in this one, aren't I? All right, that should be a 9 there. All right, so we're going to go to the right 3 and to the left 3. So 1, 2, 3. 1, 2, 3. Oh, not there. We're going to go to the right 3. 1, 2, 3. To the left 3. 1, 2, 3. You got to go from the center. I looked here and I don't know. I think I'm losing it. I'm already in a little over an hour in this video. All right. So let's draw our box here. Yeah, we're gonna get our asymptotes too. All right. So let's just go ahead and get those. So we've got our, because they ask us to find them. So that's going to be y equals what? All right, so this one's a little different, isn't it? We've got to look at our center is not 0, 0. So it's going to look a little different. So our asymptote's going to be y, let's see, there's the 2, so y minus 2, and that's going to equal plus or minus. So the y squared term came first, so that's a over bx, and then times x plus 1. Okay, it's going to be in this form. And so we've got y minus 2 equals plus or minus, that's going to be a over b, so that's 2 over 3. Whoop, that shouldn't be an x there. 2 over 3 times x plus 1. All right. So there's your asymptotes there. And, you know, like I said, draw that box in. That's going to help you sketch your asymptotes in like that. Let's come over here and draw this. All right, now is this parabola going to open up, down, left, right? Well, it's up and down, right? Because the y term came first, and so it's going to look something like this. All right, now let's go ahead and do our vertices and foci. All right, so we know our vertices are here and here, right? That's our vertices. So we're going to be adding and subtracting to the x coordinate or the y coordinate of the center. To the y coordinate of the center, right? Because we're moving up and down. So the vertices, that's going to be what? That's going to be -1. Okay, let me erase this. -1. And then let's see, the y coordinate is 2. And I'm going to be adding and subtracting what to it? See the a term 4. See, that's underneath the y. So what I do, I went up 2 and down 2. And so my vertices are what? -1, 2 plus 2 is 4. And -1, 2 minus 2 is 0. So there's my vertices. And then my foci, well, that's going to be the same thing. The x coordinate's going to stay the same. And what am I doing? I'm going up and down, right? See, I've got foci here and foci here. So we're actually, well, what? We're adding square root of 13 and subtracting square root of 13 to the y coordinate of the center. Square root of 13, that's going to be what? That's going to be about right up in here, maybe like right in here. There's your foci. So that's going to be 2 plus or minus the square root of 13. There's your foci. So there's your center, your vertices, your foci, and your asymptotes, and there's the sketch of your graph. All right, so now we are finished graphing. I know that was quite a lot. I know this video it's running long, but you know I'm trying to cover more than the examples in the book. Okay, I went and grabbed some more examples out of the exercise to do those. All right, so let's look at this. So we're done with graphing, so we're finding equations. Find an equation for the conic that satisfies the given conditions. So this is a parabola, vertex 0, 0, focus 1, 0. All right, so we know what the equations of the parabola are. We have what? Y squared is equal to 4px, or x squared is equal to 4py. All right. So for this, don't look at vertex and foci. They give us the vertex, they give us the foci. Don't look at it and try to figure out, well, which one is it? Is it x squared or is it y squared? Look, just come over here real quick. It doesn't have to be anything fancy. There it is. There's your vertex. There's your vertex. Here's your foci. So you know it's got to open this way. It's going to open to the right. And so you know you've got y squared is equal to 4px. That's what you know. And what else do you know? You know that p is equal to 1. Well, how in the world do you know that? How do you know p is equal to 1? Because isn't p the distance from here to here, from the vertex to the foci? That's 1 unit, right? This is 1. This is the point 1, 0. This is the point 0, 0. So you know p is 1. So y squared is equal to 4 times p, which is 1 times x, so we get y squared is equal to 4x. Man, that's so difficult, isn't it? See how easy this stuff is? All right. Let's look at the next one. All right, so we've got parabola. The focus is -4, 0. The directrix is x equal 2. Okay, don't panic, don't stress out. Just draw what you have. All right, so let's see. So we got 1, 2, 3, 4, 1, 2. So this is your directrix, x equal 2. That's the directrix. And then we've got, and this is your y-axis, this is your x-axis. So we're going 1, 2, 3, 4. There's your focus. Okay? Now, where's the vertex? Where's the vertex? The vertex is halfway between the focus and the directrix, right? Remember when we were graphing and we had the vertex? How did we get the focus when we had the vertex? We went up, or well, we moved p units from the vertex, right? To get the focus, we moved p units from the vertex, whether it was up, down, left, or right. How did we get to the directrix? We moved p units from the vertex. So we know the vertex is halfway between the focus and the directrix. So the distance, we know the distance from focus to directrix. We know how to find the distance between 2 points, don't we? That's what? That's 2 minus -4, isn't it? So that's 6. That's the distance from the focus to the directrix. So we have the distance from focus to vertex is going to be half of that 6, right? Which is 3. So I'm going to go over 1, 2, 3. There's your vertex right there, and we know that this parabola is going to, I know we don't have to draw the graph, but let's just draw it in there. So we can see the vertex is -1, 0. You see that? It's -1, 0. And so in this case, we have P is equal to what? Well, the distance from here to here is 3. The distance from here to here is 3. So we get P is -3. Now, how do we know P is -3? Well, this thing's opening to the left. So P is negative. Okay. All right, so what's the equation of our line? That's what we need. Well, we know that's going to be y squared is equal to what? 4 times P times what? X plus 1. Right? The vertex is -1, 0. So the X, right, has to be a X plus 1. And see, that's y squared. So we know the vertex is what? -1, 0. And so I get y squared is equal to 4 times P, which is -3 times X plus 1. And so that gives us y squared is -12 times X plus 1. And there's the equation of your parabola. All right, I promise we are almost finished. We've got 4 more problems to work. These have been going kind of quick, so, it's not too bad. And we got an ellipse. And they tell us the foci is 0 plus or minus 2, and the vertices are 0 plus or minus 3. Okay, so let's see what we got to do here. So for this one, I think what I want to do is, let's see, 1, 2, 3, 1, 2, 3. I wanna plot my vertices. Remember, that's the major axis, right? When you plot your vertices, that's the major axis. And so that tells me that we have x squared plus y squared equals 1. Now, I know I've got to put a squared and b squared in the denominator. So let me ask you this. Think about it. Is the a squared going under the y, or is the a squared going under the x? That's right. It's going under the y, right? This is our major axis. Here's our vertices. It tells us our vertices are 0 plus or minus 3. So we know that a squared is going under the y squared. And so this tells us that what? A is equal to 3, right? There's your 3, which tells us a squared is equal to 9, and c is equal to 2, right? The plus or minus 2 for our focus, our foci. We go up 2 and down 2, and so that tells us c squared is equal to 4. Well, we know that c squared is equal to what? A squared minus b squared. See, look at this. We've got a squared, okay? I need to know what b squared is, but we have to use c to get it. So this is going to tell me c squared, which is 4, is equal to a squared, which is 9, minus b squared. So if I move the b over here, the 4 over here, I get b squared equals 5, which tells me b, well, I don't need b, but let's just go ahead and write it down. B is the square root of 5, but really all I need is b squared. And so my equation is x squared over 5 plus y squared over 9 equals 1. And there's your equation. And another way that you could write this, and you remember when we had to divide by whatever this number was over here when it wasn't equal to 1? Well, just to show you, I mean, you can write it like this or not, but if we multiply everything by the common denominator, which is 45, multiply this by 45, that's going to give us 9x squared. Multiply this by 45, 5y squared equals 45. That's another way you could write the equation to that ellipse. Okay. All right, so let's go to the next problem. So we got an ellipse. The foci is at 2, -2, 4, -2. Oh, so this is kind of telling us that this thing's not going to be in the center, is it? The center of the center of the ellipse is not going to be at the origin. And we got vertices at 1, -2, 5, -2. Okay, don't try to do all this stuff in your head. Draw a picture of it. Okay, draw the picture. All right, let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. All right, so let's plot the points. We've got 1, 2, 3, 4, 5, -2. We got 1, -2. Okay. And let's see, the foci, we've got it. I'm going to do the foci in green. So that's going to be 2, -2, and 4, -2. There's the foci. So what do we need? We need the center, don't we? We need the center of the ellipse. And so the center of the ellipse is right in the middle of the distance between the foci, right? Okay. So let's see. This is the point. Let's label that. That's the point 1, -2, and this is the point 5, -2. So that distance there, that's 5 minus 1, which equals 4, right? That's the distance between them. So that tells me, and remember, I've got to get a squared and I've got to get b squared, right? And they don't give me either one in this case. But here I can see that a is equal to what? 1/2 times 4, right? Which is 2. So that tells me a is equal to 2. Now, how do I know that? Because look, this total distance here is 4, right? Well, remember, from the center, that's over and over. So I got to go over 1, 2, over 1, 2. That's A. A is half that distance from the vertices. The distance of the vertices, A is half that distance. And now, what about C? I can get C here, because I'm going to use C to help me figure out what B is. Okay, so I need this distance. So this distance, well, this has an x value of 4, and this has an x value of 2. So if I do 4 minus 2, which is 2, that's the distance between the foci. So that tells me C is equal to what? Half of 2, which is 1. So there's C. And so, well, now I can get what? Now I can get B. So I know that C squared is equal to A squared minus B squared. And so 1 squared equals 2 squared minus B squared. And so let's see, that's 4, that's 1, that's going to be 3 when I move that over there, move the B squared over here. So B, I get B is square root of 3. I know we don't need to find B, but I just did. Okay. All right. Now we can also see that this thing is not centered, right? So what's the coordinates for the center? Well, the coordinates for the center, well, I can see the y coordinate is -2, right? But what's the x coordinate? Well, if A is 2, see, A is 2, so from here I can go over, this is 1, 2, 3. So the x coordinate is going to be 3. And so my equation is, now, is A squared, is it under the x term or is it under the y term? Well, it's under the x term because, see, my major axis is horizontal. See that? See over here, my major axis, because my vertices, my major axis was vertical, so A squared was under y squared. But here, the major axis is horizontal, so the A squared is underneath the x squared. All right, so I've got x, let's see, that's 3, so that's x minus 3 squared over A squared. And what's A squared? A squared is 4, because see, A is 2, so 2 squared is 4. And then plus, and then this is y, my y coordinate is -2, so that's y plus 2 squared over B squared. Well, what's B squared? B squared is 3, and that equals 1. And there's your answer. And yes, I guess if you wanted to, you could multiply 3 by 12. I probably wouldn't on this one. I'd just leave it like that. All right, so we're moving right along. We've got 2 more to do. I hope you're still hanging with me. All right, so let's look at this one. So we've got a hyperbola. Vertices are at 0 plus or minus 1. And we've got the asymptote y equals 2x. Okay, so let's kind of just do a little rough sketch here. So the vertices are at 0, 1, and 0, -1. There's my vertices. Okay, we can see the center is at 0, 0. So this is 0, 1. This is 0, -1. Now let's see here. So the only other information they give me is y equals 2x. And I also, let's write down what else we know. We know A is 1, right? Because we did what? We went up 1 and down 1 for our vertices. So we know A is 1. And we know the y squared term is going to come first because our vertices are on the vertical axis, okay? So we know it's going to be y squared over something minus x squared over something equals 1. All right, so let's see. Well, what else do I know? Well, I know this. I know that a over b is equal to 2, right? See, they gave us one of the asymptotes. And remember, when the y squared term is first, look, let's go back up here. Let's go back up here. Just hang with me. Don't stop the video. See, when the y squared term's first, we know the number in front of x is a over b. You see that? All right. So let's come down here. Look, we're almost done. Just hang in there. All right, so we know a over b is 2, and I know a is 1. So that tells me 1 over b is equal to 2. So if I move the b up here, the 2 down here, that gives me b is 1/2. Okay, so b is 1/2. All right, so, you know, is that all we need? All right, so we've got everything we need. We've got A, we've got B. Now, let me say this. This problem here, in the book, this problem asks us to find a little more than the equation of the hyperbola. It also asks us to find the foci. So we'll do that also. But let's just go ahead and get the equation first. So we know we're going to have y squared over a squared. Well, a is 1, so 1 squared is 1, minus x squared over b squared. So b is 1/4. B is 1/2. So b squared is 1/4, and that equals 1. And so this is going to be y squared equals, now remember this is x squared divided by this, or x squared times the reciprocal. So that's going to be minus 4x squared equals 1. So there's your equation. Now, you know, for fun, let's go ahead. Let's just find the foci. So, you know, give us some more practice. So we got c squared is equal to a squared plus b squared, right? That's the foci for hyperbola. So we get c squared is equal to a squared. Well, that's 1 squared is 1 plus b squared. 1/2 squared is 1/4, which that's going to be what, 5/4. And so c is plus or minus the square root of 5 over 2. Now, remember your foci is going to be here and here, right? So what's going to be the coordinates of the foci? That's going to be 0. The x coordinate is going to be 0, and then it's going to be plus or minus square root of 5 over 2. Okay, they didn't ask us that. When I'm doing this on this video, I didn't have in the directions to find that, but they did ask for it in the book, so we went ahead and did it. All right, so last problem. All right. I know you're ready to finish watching this. I'm ready to stop making the video too. But don't tell anybody that. All right, so we got hyperbola. We've got vertices at plus or minus 3, 0, and foci at plus or minus 5, 0. Oh, and I'm sorry, you know something? I messed up again, didn't I? Let me just, let's draw that back in there. Like I told you, there's your foci, there and there. This is a hyperbola. It's a long video for me too. All right. I just kind of realized that. So let's see. Let's see. All right. So we've got vertices at plus or minus 3 zeros. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So at 3, 0 and negative 3, 0. So let me ask you this. Is the x squared or the y squared coming first? The x squared, because our vertices are along the horizontal axis. Foci, I don't really need to plot them, but they're here and here. So these are the vertices, and these are the foci. Okay, I'll label them V and F. So what do we need? We need a squared and we need b squared, don't we? So let's look at this. We know that a is 3, right? That's for the vertices. We know c is 5, because that's how many units we move left and right from the center. And we have c squared is equal to a squared plus b squared. And so we've got 5 squared is equal to 3 squared plus b squared. So that's 25 is equal to 9 plus b squared. So we get b squared is 16. So b is 4. I know we don't really need to know what b is, but I just went ahead and wrote it. And so here we go. We got x squared, and we know it's x squared minus y squared. All right. And what is a? A is 3. So a squared is 9. B is, well, or b squared, we got it right here. That's 16. And that equals 1. And there's your equation. It's that simple. It's not difficult to do. Okay. So yes, I know this was a long video. Glad you stuck around. If you're still watching, let me know in the comments if you're still watching. Kind of curious to see how many of you watched the whole thing. But you know, there it is. It's simple. The main thing, especially when you're trying to find the equations, just make a rough sketch so you can see about what you've got. So that's it. Thanks for watching. Check out my other videos. Give me a like, share, and subscribe. And I will see y'all in the next one. Later.